Hi, and welcome to this second video on the normal distribution. The first video, we just looked at the characteristics of the normal distribution, the basis behind it. In this video, we're going to start looking at how we can use that to start calculating probabilities. So, here we go. Here's an example. So we've got a battery life of a phone, and we're told that it's being modelled by a normal distribution, so the average battery life for the phone is 42 hours, and somebody's done all the testing and worked out that the standard deviation for that set of data is 7.5 hours. So what we're going to do is we're going to start working out some probabilities. It says find the probability that the battery lasts for less than 50 hours, more than 60 hours, or between 45 and 55 hours. Okay, off we go. So first thing I like to do is just define my normal distribution. So we've got x is our continuous random variable. So x is normally distributed with our mean, and there's our standard deviation squared. Remember, when we define it like this, we use the variance, standard deviation squared, so that's 7.5 squared. Right, what we've got to do is find the probability that x is less than 50. And so what I'm going to do, and let's say this goes back to what we always used to have to do before calculators do what they do now, and so you'll find your teachers will probably all default to this one. Not entirely necessary, but it's a good idea. Let's draw a little sketch just so we can have a little think about what's going on. So there we go, we need to find the area of the purple bit that's under the curve there. Now we can get all those values off the calculator, but the sketch just gives us an idea, because we know on a normal distribution, that point there at 42, because the data is symmetrical, you've got half the data down here, half the data up here, so straight away that gives me a sense that I'm looking for a value that's going to be somewhere over 0.5. Okay, now, back in the day, as I said before, what you used to have to do was look up some values in a table. There's a massive tables, and you'll still find those tables in the back of your formula booklet if you want to use them, but why would you at the moment? You've got a calculator, and you've got a calculator that's now got all those data values stored in them. I'm not going to go through the exact process because it's slightly different depending on which calculator that you're on, but so you'll need to have a look, and there's plenty of videos out there that will show you specifically your particular calculator how to deal with a normal distribution. Plug the values in, and there we go. You end up with a value of 0.8569. So the probability that our battery lasts for less than 50 hours is 0.8569. On we go. Probability that x is greater than 60. There's our curve again. You can see I've got this tiny bit down here, which is our shaded area. That's the area I'm looking to find. So again, grab the calculator, and depending on what calculator you've got, it might be able to, you have to kind of redefine things that you're finding. Before we were finding the area below, so it's a left tail. Here we've got what's called a right tail, because it's to the right of our value. Or it might be you've got to do make use of the fact that the total area under the curve is 1, and if your calculator just gives you the area to the left, then you might have to do a kind of a 1 minus to find the area to the right. However you do it using your particular calculator, you end up with a value of 0.0062, so it's highly unlikely that your phone's battery is going to last for more than 60 hours. And then finally, part C, what we've got to do now is find the probability we're trapped between two values, between 45 and 55, so we're looking for an area that's essentially a strip. And again, it's a case of chuck it into the calculator. You should be able to put in upper and lower values on your calculator, and out comes the answer, 0.3031. Right. And the final point, just to note, just at this point, is that when you're working with the normal distribution, you're always going to be finding ranges of values below 50, above 60, in between two values. It's not physically possible, for example, from normal distribution, to find what's the probability that your battery lasts for exactly 50 hours. The reason for that is the data is continuous. So if you think about how many different numbers there are on that bottom axis, well, there's an infinite number depending on how accurate you're going to be. So I might be able to say, well, what would be the probability of it being exactly 50.2, for example, or 50.27, or 50.278, or depending on how accurate you're going to get. So essentially, because there's an infinite number of values on our number line that our continuous data can take, the concept of actually finding a particular value just doesn't exist. Which means, well, you don't have to worry massively about being strict on your inequalities, less thans or equal to or less thans, and like I say, you're not going to be asked to find what's the probability that it's going to be, for example, exactly 50. Right, moving on. So we've looked at examples where you've got to find probabilities using the curve. Let's have a look now about going the other way around. So let's say we know the probability that an event will happen, and we want to know the related value. This is massive. You always have to be able to do things back to front. You know, if you've got times you can do a divide. If you've got an add, you can do a plus. If you can find a probability, you can reverse it. So what we're going to do is we're finding the probability, which is the area of the curve, given a particular value. So if I know what my probability is, how can I find out what that value of A is going to be? So we've got that statement there. So the probability that X is less than A is P. And again, on your calculator, you will find an inverse normal distribution function, which allows you to do that. So here we go. We've got X is distributed normally. We've got a mean of 15. Now, the thing to watch out for is that value there. That is sigma squared. So if that's 10, that means your standard deviation is going to be root 10. So again, you've got to be a little bit careful in terms of how that's being described. And so now we've got our two values. We've got 15 and root 10. We've got to find what's the probability that X is less than a certain value is 0.45. Well, we know some facts. We know straight away that our value of A is going to be below the mean. So a little sketch tells us that we're going to be looking at something like that. So that area there is 0.45. That's the value of A that we're looking for. And so we know straight away that we're going to be expecting an answer less than 15. So it just gives us an idea of how big the number is going to be off our calculator. And if you put it into the calculator, you find the inverse normal distribution, and you end up with a value of 14.6. And on we go to part B. The probability that X is greater than a certain value A is 0.12. So let's have a quick think about the sketch. There it is. So we've got to have our area is 0.12. It's bigger than the value, so we've just got a small section up here, because obviously we know if we took the mean here, everything above this would be 0.5. So we've got a small section. It's going to be this 0.2 above that there. So there's our 0.12. And again, it does depend on your calculator how you're going to deal with this one. It might be you need to have a little think about what's going on to the left of that value. So I'm just going to put that in there. So it might be your calculator needs to work with that value there, because on your inverse function it will only give you the values to the left. Some will do just values to the left. Some will do both. So you just need to have a look at your calculator. So it might be you're working with the 0.88 figure. It might be you're working with that 0.12. Either way, when you work it all out, you should end up with an answer of 18.7. And it'd be a good idea just to kind of pause the video as you go along here and just kind of check you're getting the right values off your calculator. Okay, on we go. That's the first two done. Let's go to part C. What we've got here is we've got a value that's a probability that's in between two values, and the lower one is missing. So how are we going to deal with that? So again, there's my little sketch, and it's a 5-second job to draw a sketch. It's hardwired into me. It might be you decide you don't need them. I kind of tend always to do it. So if we work out, first of all, the probability that X is less than 18, we find that that's going to be 0.8. So that's just using our normal, the regular normal distribution function, not the inverse one. And so that means that the probability that it's less than A, that section there, is going to be the 0.8286 minus the 0.3 here. So this section here that I'm looking for, this purple section, is going to be 0.5286. So that's the bit that I'm now going to work with. And so once I've got that figured out, all I've got to do now is just go to my inverse normal distribution function on my calculator. And there you go. There's your value for A. Okay, so last thing we're going to do now, a quick contextual example. So there we go. We've got a military course, takes the top 5% of candidates based on the fitness test. So they do an assault course or whatever it is, and the mean time for that assault course is 60.2 seconds. You've got a standard deviation 8.4 seconds. What value should they set as the threshold to take people onto the course? So there's our normal distribution. So I've got my random variable calling it y, normally distributed. There's our mean, standard deviation squared. That's our variance. So what do I need? I'm looking for the top 5%. So I'm looking at the people who took the least time to do it. So I need to know the value below which only 5% of people scored below a certain time. So that's what I'm going to put into my inverse normal distribution function on my calculator. And if I do that, I get a value of 46.4. So therefore we're saying the pass mark or the time they've got to beat to be able to get onto the military course is 46.4 seconds. And there we go.